Descriptive Statistics, examining distributions and relationships in data. Statistics is the science of data. Data are simply measurements or characteristics about something. Data can either be quantitative or categorical, and we'll work with both types. Quantitative data are of course numerical and measure how much or how many of something. Categorical data are usually attributes or characteristics such as male-female or yes-no. It's important to note that categorical data can sometimes be expressed numerically, simply using numbers as labels. Quantitative data also can be grouped into categories. If you have open the Excel tool, Descriptive Statistics, you can see the data set that we'll be using as we work through the different methods. This is a sample of data on credit card holders. The highlighted variables, amount charged or amount category, those are important variables because those are our dependent variables. The other variables are what we might call cardholder demographics. So in this program, we're going to be looking at simple descriptive methods to look at who a cardholder is and how those demographics might impact their spending. Using Excel, our data are collected into what we call a data set. It's arranged in rows and columns. Each variable in our data set is a column, and each row is what we call an element. In this case, a person who has this credit card. The data set is a sample of n equals 109, our first symbol, n. It was taken at random from a population. A population, unlike a sample, is all elements of interest, in this case, all cardholders, whereas our sample is simply a subset of that population. We're going to begin our analysis with descriptive statistics. Descriptive statistics uses charts, graphs, tables, and numerical methods to summarize a sample of data that we possess. Descriptive statistics can be run for a single variable, and we call that examining a distribution, or examining the relationship between two variables. In addition to summary, descriptive statistics is foundational to examining the data and helping us determine if it's appropriate for using statistical inference methods. Later in our program, we'll use statistical inference, which is different than simple descriptive statistics. Statistical inference is a process of making guesses or inference about an entire population. Statistical inference, therefore, goes well beyond the descriptive information obtained from a single sample of data. However, all inference is based on that sample data. So the process of statistical inference should begin with a descriptive analysis of the sample data. So let's begin our descriptive statistical analysis of our credit card data, and we'll begin with examining distributions. So we're looking at either a categorical variable or a quantitative variable, only one variable at a time. Let's begin by examining the distribution for a categorical variable. Here, the education level of a credit card holder in our sample of n equals 109. We're going to identify three tools we have for summarizing a categorical variable. One is called a frequency distribution. Since the data are already in categories, we're simply counting how many in each category. In other words, how do the data distribute across these categories? This is why we call it a frequency distribution. From that simple count, we could also determine relative frequency and the very familiar percentage. Our two visuals, our bar graph and our pie chart, are also going to be created. We can easily create our frequency distribution, bar graph, and pie chart using the Descriptive Statistics Excel tool. On the main data page, we can see the input for a categorical variable. We would want the variable number 5 input there because education level is variable 5 in our data set. We also need for a categorical variable the category labels. Here we have 3, BA, M, and D. So once we input the variable number and the category labels, we then go to the worksheet tabs below. Click on the tab Categorical to see our results. Our frequency distribution shows that we have mostly BAs in our sample, 66 out of 109, or 61%. The relative frequency is also known as the sample proportion p-hat. This is an important sample statistic when working with categorical data. For example, the sample proportion of master's degree cardholders is 0.23. Categories may be combined. The sample is about 60% undergrad, for example, and 40% graduate level. Now let's go to our Excel tool to practice using our descriptive methods for examining the distribution of a single categorical variable. We've already worked with education level, which is variable 5. If we input 5 for a categorical variable, and then our 3 category labels, B, A, M, and D. The Worksheet tab Categorical has our results, and we can capture these results and add them to a report. Table 1, our frequency distribution. Figure 1, our bar graph, for example. And we could provide a good descriptive summary of the education level of the cardholders in our sample. Let's try another one. Back to the data sheet. Gender is also a categorical variable in our sample. That one's variable number 4. Update our labels to M and F. Categorical worksheet has our results. And we can see that there is a proportion of 0.45 and 0.55 in the 2 gender categories. And we could capture these results as well. We could try one more. We also have variable number 8, which is marital status. And we have that in 3 categories. Variable number 8 has the category labels S, M, and D. Our Worksheet tab Categorical has our results. Now let's look at quantitative data. When doing a descriptive analysis of a quantitative variable, we're mainly looking for 3 things: shape of the distribution, the center of the distribution, and spread. The histogram, NQ-plot, and box plot are 3 tools that we'll use to show shape. These plots also show possible outliers in our sample data. The sample mean is an important measure of center. The sample mean has the symbol X bar. The standard deviation for our sample, S, is a measure of dispersion. It shows how the data spread out around the mean. And the sample size N is always reported. Using our Excel tool, Descriptive Statistics, we can easily run a descriptive analysis for a single quantitative variable, such as variable number 3, amount charged. By inputting variable 3 for a quantitative variable, our results will be on the worksheet's histogram and NQ and box. When examining shape, we're looking for 2 possibilities, either an approximately normal distribution or a distribution that is clearly skewed to the right or to the left. All 3 of the plots shown, the box plot, histogram, and NQ plot, are for amount charged. All of these show an approximately normal distribution. All plots show central tendency, or the tendency of data to cluster in the middle of the distribution. And we could also see approximate symmetry in the upper and lower tails of the distribution. We avoid saying slight skew or mild skew. Instead, we would say it's approximately normal. Skew is particularly notable when it is clear and when the sample size n is small. The worksheet NQ in box shows z-scores for all data. It also counts any z-scores beyond positive 3 or negative 3, which is a standard for characterizing a data point as an outlier. The z-score measures simply how many standard deviations a data point is from the mean. Any data point that's more than 3 standard deviations from the mean would be off the normal curve and easily characterized as an outlier. The mean and the median may also be used to determine shape. When close in value, the distribution is approximately normal. The mean is affected by outliers, but the median is not. So when the mean is greater than the median, it generally indicates skew to the right. Less than the median, skew to the left. When our data fits or compares favorably to a normal distribution, most data will be around the mean, plus minus 1 standard deviation, and nearly all, as you can see, 95% within 2 standard deviations of the mean. So completing our analysis of the amount charged variable, remember we're looking for shape, center, and spread. Our sample mean amount charged, $4,122.14. Our standard deviation S, 970 and 30 cents, for our sample size of n equals 109. The distribution of amount charged is approximately normal, and according to the z-scores, there are no outliers. Now let's go back to our Descriptive Statistics Excel tool to practice using our methods for a quantitative variable. We've already worked with variable number 3, the amount charged. If we input the variable number 3 and tap on our histogram, we could see our results, which we've already reported. If we go back to the data sheet, let's pick a new quantitative variable like income, which is variable 1. So if we change the variable number to 1 and then back to our histogram, we could see that the distribution of incomes is approximately normal. That is, there's no strong skew, central tendency, approximate symmetry. Our mean is 133.872 and our standard deviation 46.4 for our sample of n equals 109. Tapping the Worksheet tab NQ in box, we could see our normal quantile or NQ plot. We use the NQ plot to assess how closely our sample data follows a normal distribution. Sometimes we can see central tendency, but we often can see upper and lower tail areas of the distribution. That is, less data as we move out toward the max and the min. Our box plot aligns with what we call the 5-number summary. On the extremes, we have the min and the max. The box is what we call the interquartile range, and it is the range of the middle 50% of our data, from the 25th percentile to the 75th percentile, and Q2, the median, is the vertical line in the center. Let's try one more. Household size is also quantitative. However, household size is what we call a discrete quantitative variable. Our data are in whole integers, 1, 2, 3, and so forth. And importantly, there's no values between 1 and 2, or between 2 and 3, and so forth. That's what makes it a discrete quantitative variable, but we can still use the same method as we did for other quantitative variables. We can also see that our household size distribution is skewed to the right. When we note a skewed distribution, we need to be careful to check for outliers. Our NQ and box plot sheet shows no z-scores beyond 3. They're counted right here in these cells, but we could also scroll the outlier column to see if any of the z-scores are flagged as possible outliers. The spreadsheet will always mark a z-score that's beyond 3.